Hi, in this video, we'll be going through a couple of exercises related to stoichiometry and quantitative relationships. So we're going to have 15 problems of varying difficulty. So magsistart tayo sa mga easier questions, and then we'll increase the difficulty until doon sa coverage at the end of the chapter. So if you have any questions, feel free to send an email or send a message sa group chat natin, okay? So let's start with number 1. In question number 1, we're being asked how many moles of C atoms are in 1 mole of sucrose. So binigyan na tayo ng chemical formula ng sucrose natin. Now there are 2 ways you can answer this. First, you can just say, kasi binigyan na tayo ng chemical formula, di ba? That chemical formula already tells us how many moles of each atom is necessary to create 1 mole of the compound. So sa chemical formula pa lang, alam na natin that, so based on the chemical formula, there are 12 moles of carbon in ano yun? C12H22O11. Also, you can do it quantitatively for moles of carbon, starting with 1 mole of sucrose. So every mole of sucrose is equivalent to 12 moles of carbon. And then yung moles of sucrose, makrush out siya, and you're left with 12 moles of carbon. So you can do it quantitatively like this, or you could use an explanation like the one on top. Okay? Now, on number 2, we are given a situation. So you need to calculate the number of phosphorus molecules that can form from 2.5 grams of calcium phosphate. Now, hindi tayo sinabihan na mag-solve. Pinapagawa lang sa atin is to draw the roadmap. So what's your plan for solving this without doing any calculation? So we're going to draw a diagram that you can see sa book. If any of you open the reference books that I provided, you'll be able to see yung mga diagrams doon. So that's what the roadmap they're talking about is. So where do we start? Always start with what's given. That's 2.5 grams of calcium phosphate. So what's grams? Diba? That's mass. So kailangan natin is, dito natin ilagay, number of P4 molecules. You have 2 different compounds right there. So you have a compound A, calcium phosphate, and compound B, which is the phosphorus. Now, if you have to convert quantities between 2 different compounds, kailangan natin gumamit ng molar ratio. And to use molar ratio, kailangan natin i-convert yung mga hindi naka-moles, convert natin into moles. So that means we have to convert this given mass here into moles of calcium phosphate. And then convert natin yung moles calcium phosphate into moles of P4. And then yung moles of P4, pwede na ma-convert into number of P4 molecules. Now, what do we use to do these conversions? So to convert grams into moles, diba, we would need to use yung unit na grams per mole. That's the molar mass. So use the molar mass of calcium phosphate. And then to convert from moles of compound A to moles of compound B, we would need the balanced na chemical equation and yung accompanying natin na molar ratio. Di ba pag mabalance mo yung chemical equation, meron siyang stoichiometric coefficient. Yung stoichiometric coefficient, yan yung gagamitin natin as molar ratio. And then to convert moles of phosphorus to number of phosphorus molecules, gagamitin natin Avogadro's number. That's diba, Na. Na is the symbol for Avogadro's number. That's 6.022 times 10 to the 23 entities. When I say entities, meaning pwede yan number of atoms, number of number of ions, number of molecules, etc., etc. So yan, so this is our roadmap now. Ganun lang, without doing any calculation. So if you're given the reaction, since you already have the given starting mass of calcium phosphate, then you can do the calculation following the steps outlined in this roadmap. Now let's go to number 3. We have to calculate the molar mass of two different compounds. First, CH2Cl2. How do we calculate the molar mass? Diba? To calculate the molar mass ng isang compound, i-add lang natin lahat ng molar mass of a particular element na component doon na compound times how many atoms of that particular element there is. So for CH2Cl2, that's going to be, isa lang yung carbon natin, so diretsyon na natin. Huwag na natin ilagay yung times 1. So that's 12.01 grams per mole plus 2 times 1.008 grams per mole plus 2 times 35.45 grams per mole. Now, if hindi nyo pa kabisado yung mga atomic weights na ginagamit ko dito, you have to look at ptable, ptable.com. Okay? Okay, so we now put all these numbers into the calculator and now we have the value 84.926. Now if we round that up to the number of significant figures in the atomic weights that we used in the atomic masses that we've used, we're gonna have 84.93 grams per mole. So that's actually the molar mass of each element that we use. Again, if you don't remember, galing sa atoms, molecules, and ions natin na chapter, atomic weights have the unit AMU. Molar masses of an element or the molar masses of compounds have the unit grams per mole. Same numerical value, just different units. Now let's proceed to letter B. So letter B, that's CaC2H3O2, quantity 2. So that's 39.10 grams per mole plus pareho sa math where 2 times A plus B will become 2A plus 2B ma-distribute sa loob ng parentheses. This subscript na nasa labas ng parentheses will be distributed to the elements inside it. Pag pag naka-parentheses, kung walang parentheses, edi wag mong i-distribute, okay? So that's going to be 2 times 2 times 2. So that's 4 times the molar mass for carbon, that's 12.01 grams per mole, plus 3 times 2, so that's 6 times 1.008 grams per mole for hydrogen, and then 4 times 16.00 grams per mole, that's for oxygen. So we put all those values into the calculator. That's 4 times 12.01 plus 6 times 1.008 plus 4 times 16. So now we have 157 Diretso ko ng i-round off. That's going to be 157.2 grams per mole. Now, do not forget to put the units in your final answers. Without the units, that's just a dimensionless number. So I will not be considering that as a molar mass. Kasi hindi nyo nilagyan ng unit. For all I know, that could be 157 meters, 157 grams, or even 157 tons, di ba? Kasi wala nga unit. So it is important, since science demands clarity, that we always include units, especially in our final results. So number 4 tayo. So number 4, we're being asked to calculate for the amount in moles for 1.6 times 10 to the 22 atoms of copper, and then letter B for the mass of 6.44 times 10 to the negative 2 moles of manganese sulfate. So saan tayo magsa-start? For letter A, start with the given. So 1.36 times 10 to the 22 atoms of copper. To convert that into moles of copper, yung gagamitin natin na conversion factor will be Avogadro's number. So Avogadro's number is 6.022 times 10 to the 23 atoms of copper per 1 mole of copper. So yun na. We're just gonna put that in the calculator. So if we put that in our calculator, we're gonna have 1.36 times 10 to the 22 over 6.022 times 10 to the 23. So you'll have 2.26 times 10 to the negative 2 moles of copper. Diba? If you have 0.02258, that's, you're gonna move the decimal, that's 1, 2. So magiging 2.258. And then times 10 to the negative 2 kasi you moved 2 places to the right. Kaya naging negative 2. And then yung 258, you have to round that up kasi meron lang tayong 3 significant figures here. So it's gonna be 2.26 instead, right? Now that we're done with letter A, let's go to letter B. Erase ko ha. Now, letter B tayo. So sa letter B, we have here, asa na ba? Hinahanap is mass, or that's grams of manganese sulfate. So we start with the given number of moles, 6.44 times 10 to the negative 2 moles of MnSO4. Tapos, kailangan natin i-convert into grams, MnSO4. To do that, we're gonna use molar mass. So moles sa baba to crush out this one here, and to end up with grams na lang nasa taas. Now, what is the molar mass of MnSO4? So magsosolve pa tayo separately. SO4. Now, again, if you are unfamiliar, hindi nyo memorize, then you are very free to use ptable.com. Again, that's ptable.com. You can see a very interactive periodic table. So paglaruan nyo yung site na yun, you will see a lot of information. Okay, Mn is 54.94 grams per mole. So grams per mole plus sulfur, which is 32.06 grams per mole. And of course, 4 times 16 grams per mole. If we put that in the calculator, you'll have 151 grams per mole. Exactly 151 grams per mole. And then So 151 times 6.44 to the negative 2. So now you have 9.72. So three significant figures lang. Grams, MN, SO4. Okay? Now, following that, we have number 5. So sa number 5, may A and B din. Pinapakalculate sa atin yung mass ng 1.83 times 10 to the 24 molecules of dichlorine heptoxide, and letter B, mass percent of oxygen in sodium dihydrogen phosphate heptahydrate. For now, I'll be the one giving the chemical formulas, but in the problem sets and in the exams, you'll be the one to look for it. I think that I think that's all right because you have the internet anyway. If it was a face to face, then it would be a different matter. But everything is online, so you can use your resources at your disposal. So let's go for letter A. We're looking for mass of dichlorine heptoxide, diba? Di meaning two, so dalawang chlorine. Heptoxide meaning oxygen, and then the prefix hept meaning 7. So kaya tayo may Cl2O7. So let's start with the given 1.83 times 10 to the 22 molecules. Kailangan natin is grams, and to do that, we first have to convert the number of molecules into moles. And then after moles, we convert moles into grams. To convert molecules into the number of moles, we have to use Avogadro's number. Oops, mali. Ay, sakto pala yun. Sorry. And then to convert moles into grams, we need to use the molar mass. So let's get the molar mass of Cl2O7. That will be 2 times 35.45 grams per mole plus 7 times 16.00 grams per mole. So if you put that into the calculator, you'll end up with a molar mass of 182.9 grams per mole. Now, in these cases na hindi hindi integer, hindi whole number, yung makukuha niyo na molar mass, please do not round off ha. Doon na tayo mag-round off sa end na value. So you put this whole molar mass as it is dito. So that's 182.9 grams. Okay. And then we put all these values inside the calculator. So your grams Cl2O7 would be, that's 1.83 times 10 to the 24 molecules times 182.9 all over 6.022 times 10 to the 23. So you end up with 555.807, which will be equal to 555.8, or just 556 grams of Cl2O7, right? There we go. Cl2O7. Now let's go for letter B. So letter B, we're being asked for mass percent of oxygen. Now, always, di ba, pag percentage, that's going to be partial all over the total, or component all over the total times 100. Meaning that's going to be moles or grams. Actually, putting moles, putting grams. But for this instant, we're going to use molar mass times the number of oxygen atoms. So that's going to be, una tayo muna. What's sodium dihydrogen? Dalawang hydrogen. Phosphate is PO4. Heptahydrate meaning hydrate meaning H2O and hepta meaning 7. So ilang oxygen meron dyan? That's 4 plus 7 times 1. So that's 11 times the molar mass of oxygen, that's 16.00, all over the molar mass of this whole thing right here. So that's 22.99 plus 2 times 1.008 plus 30, what's this again? 30.97 plus 11 times 16 plus 14 times 1.008. Since pareho naman silang oxygen, pwede nyo itong isahin, magiging 16 times 1.008. But that's gonna give us the same answer, which is 246.088 grams per mole. So, ilalagay natin yan dito sa baba. So 11 times 16 all over 246.008, you will have times 100, you'll have 55.67%. So in each 100 grams, 55.67 yung oxygen, 55.67 grams. Okay? So number 6. In number 6, we are given a situation where iron, that's Fe, slowly reacts with oxygen and water to form a compound commonly called rust. Binigyan tayo ng chemical formula ng rust. That's iron oxide, iron 3 oxide, and then 4 hydrates. So for 45.2 kilograms of rust, calculate the moles of the compound. So i-calculate yung moles ng Fe2O3 4H2O and the moles of Fe2O3 and then grams of Fe. Okay, so let's start with letter A. Doon tayo sa given. Given natin is 45.2 kilograms. Now, our molar mass is usually in grams per mole. And although we can convert that into kilograms per mole, mas madali ata kung yung kilograms you convert natin into 1,000 grams. Para yan lang. Less chance of getting the conversion factors wrong. So now naka-grams na, we'll just need to get the molar mass of Fe2O3 Fe2O3 4H2O. So, kunin natin yung molar mass. So, that will be, that's 55.85 times 2 plus oxygen, that's 4 times 16. 4 kasi 3 plus, mali. That's 3 plus 4 times 1. So, dapat 7 plus 8 kasi 4 times 2. 8 times 1.008 grams per mole, which will give you 231.764 grams per mole. So, lalagay natin yan dito sa baba, 231.764 grams per 1 mole of the compound. So crush out, crush out, crush out, crush out. You're left with moles Fe2O3 4H2O. If you put that in the calculator, you should get 195.026 moles. Or if you round it up to the correct number of significant figures, that's 195 moles. Gets? Okay. Letter B, we have moles of Fe2O3. Wala nang 4H2O this time, ha? So let's just get all of these kasi kailangan pa naman natin yung number of moles ng Fe2O3 4H2O. Sulat ko lang ulit. Now, if you see here, for every 1 mole of this compound, 1 mole lang din yung Fe2O3. So that's just 1:1. So since wala naman tayong factors na makakapag-change, 1:1 lang yung dinagdag natin, the answer will remain the same. It's still going to be 195 moles. However, this time it's not Fe2O3 4H2O, but just Fe2O3. Okay? Now let's proceed to letter C. Sa letter C, grams of Fe, yung hinahanap sa atin. Magsisimula pa rin tayo sa 45.2 kilograms of Fe2O3 4H2O. Now, all you have to do now is to convert that kilograms of Fe2O3 into grams of Fe. So, convert kilograms into grams of Fe2O3 4H2O. Convert that grams into moles. So, ano yung molar mass kanina? Molar mass kanina is 231.764 grams. So sa taas is Fe2O3 4H2O. Ngayon, yung kailangan natin is the molar ratio between these two. Since wala namang reaction na involved, 'di ba? Walang reaction na involved. Kasi yung Fe lang dito sa Fe2O3 4H2O yung pinag-uusapan natin. We can just look at the chemical formula. Tingnan natin kung ilang Fe atoms meron yung isang mole ng Fe2O3 4H2O, which we can see that's 2. So now we have the number of moles ng Fe. To get the mass from the number of moles, we just use the molar mass. And we already know the molar mass of Fe, diba? So the molar mass of Fe, for every mole of Fe, we have 55.85 grams of Fe. And if you put that into a calculator, you'll have 21.784 grams of Fe, or just 21.8 grams of Fe. Okay? Okay. Now let's go to number 7. For number 7, you have this question. Find the empirical formula. So umabot na tayo ng empirical formula of 0.062 moles of chlorine atoms combined with 0.22 moles of oxygen atoms. Tingnan natin. Ano yung mga steps natin for getting a empirical formula? 'Di ba? Kung naka-percent, naka-mass percent yung binigay, assume 100 grams para makuha natin yung mass in terms of grams. And then convert grams into the number of moles. Na yung binigay sa atin is already in the number of moles. So we don't need the Mass percent, we don't need the mass. Diretso na tayo sa step kung saan i-divide natin yung smallest mole value. Mas maliit yung 0.062 kaysa sa 0.22. So, what's gonna happen is 0.062 divided by 0.062. Yung sa kabila, that's oxygen. So 0.22 divided by 0.062. So this is equal to 1. So you have 1 Cl, 1 Cl atom, and then yung kasama niya would be, this is 3.5. That's O 3.5. Now, dun sa rules natin, di ba, bawal tayong mag-subscript ng mga 0.5. To get rid of that 0.5, we multiply everything by 2. Yung mga subscript niya. So that's Cl sub 2 and then O sub 7. So that's the compound that we saw kanina, dichlorine heptoxide. So yan yung EF niya. Okay? Now let's go to number 8. A chloride of silicon, so some compound of silicon chloride contains 79.1 mass percent chlorine. What is the empirical formula of the chloride? If the molar mass is 269 grams per mole, what is the molecular formula? So yung tinatanong is empirical formula and the molecular formula. So to determine the empirical formula, since binigyan tayo ng mass percent, we'll just assume 100 gram sample. Now it's very important if you're putting assumptions, if you're doing assumptions, then you should put your assumption. So ano yung assumption nyo? Hindi yung mag-a-assume pa ako kung ano yung assumption mo. That's very convoluted, di ba? Assume na lang tayong lahat. So, we have moles chlorine and moles silicon. So, kailangan natin naka-assume na tayo, di ba? So, out of 100 grams, 79.1 grams will be chlorine. Convert natin into moles of chlorine. So that's 35.45 grams per 1 mole of chlorine. And that's equal to 2.23 moles of chlorine. Now for silicon, that's going to be kung ano yung sobra. Diba? Sa percent. So that's 100 minus 79.1 grams of silicon, which is 20.9 times the molar mass of silicon. So that's 28.09 grams per 1 mole of silicon, which is equal to 0.744 grams of silicon. Since mas maliit si silicon, moles pala to. Mas maliit yung moles of silicon kaysa sa moles of chlorine, yan yung i-divide natin. So 2.23 divided by 0.744, that's equal to 2.99. Round up na natin yan sa 3. And then yung silicon is 0.744 over 0.744 is equal to 1. So the formula for our chloride of silicon will be Cl3S. That's Si pala. And that's it. Okay, now we're halfway there. We are gonna be on question 9 out of 15.